Hello, this is Yanis from Any Repair. Today we'll go through an IO, an HP Pro 440 G9 all-in-one computer that came to our lab dead. This is a very easy job, a very easy repair that you can do, anyone can do, with a minimum experience on soldering. You will understand what I mean. So let's go and see how we'll deal with damage. This is the all-in-one computer that is dead, and now we're going to measure with our multimeter uh, the possible cause. So we're going to check the main rail, which is short. Yes, it is. It is something like a notebook, and this capacitor is short, and this capacitor is short. These capacitors are filtering the main rail, the 19 volts. We are dealing with a computer, but I will treat him as a notebook because the architecture is the same for all electronic devices. The only difference is that this computer has not charging feature, of course, because it's a desktop. Let's go and see under the microscope. Under the microscope, this is the DC jack. Wait for me to focus. It's not very easy. It's a big device. I'm trying to focus and fit this device on my desk. So you can see like a notebook, you can see MOSFETs, two MOSFETs that are in parallel, and a current sensing resistor that seems to be short. Let me touch it properly. Maybe the ground I'm touching is not very good. Not, it is good. Now you can see that it is. We are having a short on the main rail. You can see the down left filter. It's a bit damaged. We are definitely having a short. Now let's go on these purple and silver capacitors. These are 2.5 volts. You can see it. You can see it. The other one are having like 25, which I think they're the voltage that they are capable on filtering. And we are having a short definitely in the main rail. The capacitor is short, so all the rail is shorted. And now we must figure out what is short and how we will remove the short in order for the computer to be fixed. We will add some flux on the beginning of the main rail. This is the common action we must do. So we will solder a wire from our custom DC jack and the ground to the screw pad. And now we will add some voltage in order to begin the voltage injection. Okay, it could be larger amount of current. The current cannot harm the computer. The voltage, remember that the voltage harms the computer, not the amps. So we will limit the voltage to 1.3, and it's drawing, the consumption is 1.6 1.5 amps. Now we are going to search for something that is burning. Let's switch to the thermal camera. You can see something around here. Oh, okay, that was not very wise. Okay, let's go. We are having the Mobo on our desk. It's removed from the chassis, and I have left the my custom DC jack soldered, and now we are drawing 2.4 amps, and something is burning. Let me remove the DC jack. This is okay. And here something is getting very hot. Let's go and see. Go, 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 thermal camera. So, something is not very well on this mainboard. Something is burning hot. Cannot focus the thermal image because I am holding the thermal camera on my left hand. Now, under the microscope, this is the area that was that is burning hot. You can see that the isopropylic is evaporating instantly. I am pretty sure that this is a capacitor. That's why I told you at first, in the beginning of the video, that it's a very easy repair with minimum or limited soldering skills. That is required for you to do it yourself. It could be a DIY if you are having a multimeter, a soldering iron, and some flux and a tweezer. So the capacitor on the right, I think, it's not in a good shape. So we will remove it. At first I was trying to remove it with my soldering iron, but it is not good. It make me work harder, so I decided to use my hot air gun. We could just remove it by a screwdriver from the board, but I want to replace this capacitor. So I am removing the capacitor with my heat gun and a tweezer. And now it's the time to measure if the fault is gone. If the short is gone, I will test on my DC jack leads. You can see we are having a very nice main rail voltage drop, so I think the problem is solved. But this will not be solved if we're not having a display on the desktop. So I will, as I said, I will replace this cap. And we will proceed further. I don't know the exact capacity of the capacitor, but I will replace it with my higher 25-volt capacitor, higher capacity 20-volt capacitor that I am having in my arsenal, so the filtering will be good. So let's go and replace it with my heat gun and my tweezer with the low airspeed, and only using my video, not my diopters, my optics, my my microscope, not Microsoft, oh god, optics. That's why I'm poking this coil, because I cannot see properly, and now I will use my eye optics and not my monitor. So let's go and fix this mess. And when this is fixed, we will try and check if we are having a working computer. This coil is moving, poking. I'm poking the capacitor. I think we are good to go. So let's go and test. I have assembled the notebook, not the notebook. Sorry, I'm very used in notebook repairs. The all-in-one desktop. I'm using a proper adapter, and nothing. I'm not on my desk. I am recording with my cell phone. Nothing happened. But why? Maybe. Okay. I should press the button. Okay. And the fan is spinning. I'm very dumb sometimes. And we're having a picture. We're good. I think. Not I think. The problem is solved. We're having display, so the problem is solved. Of course. It is doing something like RAM training, because it is rebooting. The fan is spinning. Okay, it is good. It is good. Nice. That was a repair, as you saw. If you liked this video, consider like, subscribe, and share. Thanks for watching. See you in another repair. Bye.